Solving equations and sketching. You need to be able to sketch two equations on a set of axes, as well as solve equations then based on those graphs. So this is best shown with an example. On the same diagram, sketch the following curves: y equals x, x minus 3, and y equals x squared, 1 minus x. Well, if we're going to sketch those, y equals x, x minus 3, that's a quadratic. It's got a positive x squared, so it's U-shaped quadratic, and it crosses the x-axis at 0 and 3. So we can sketch that, put down the appropriate numbers of where it cuts the x and the y axis, 0, 3 and 0. X squared 1 minus x, that's a cubic. It's minus x cubed, so it's going to be a negative shape, a downward squiggle. It crosses through 0, which is the repeated root, and 1. So that will look like that. So we've sketched both, and we can now use this to help find the solutions. So now we've sketched it, we can find the coordinates of the points of the intersections, i.e. where they cross. And we can see that it crosses a number of times, and sketching the graphs gives us clues of how many answers we're looking for. So on the solving front, we're solving x, x minus 3 equals x squared 1 minus x. We can expand the brackets out. We can rearrange. And then we can factorise, and then we can say that either x is equal to 0 or x squared minus 3 is equal to 0, i.e. x squared is 3 and x is plus or minus root 3. And we can see that corresponds to our sketch, because we can see in the sketch it crosses at 3 places. It crosses at one x value, which we now know is minus root 3. It crosses again at 0. And we can see the third cross quite clearly at positive, we now know it's plus root 3. It's a bit bigger than 1. We can see that from our sketch. Once we know the x values, we can substitute in each of the x values to find the corresponding y values, and hence the corresponding set of coordinates. On the same diagram, sketch y equals x squared, x minus 1, and y equals 2 over x. Now initially we don't know how many solutions we're looking for. That's why the sketch is the best way to start. So we've got x squared, x minus 1. So that's going to be a cubic. It's got positive x cubed, so it's going to be an upwardly squiggled cubic. And it's got a repeated root at 0 and another root at 1. So it's that shape there. 2 over x is a reciprocal graph. It's positive, so it's going to be in the first and the third quadrants. We know that reciprocal doesn't cross the axes. It's got the asymptotes, which are the x-axis and the y-axis for this particular graph. So now we can see that there are going to be 2 solutions to the equations when we solve them. So we can see there are 2 solutions. Essentially we have to solve this equation here, x squared times x minus 1 equals 2 over x, which we can rearrange to be x squared x minus 1 minus 2 over x is equal to 0. The only trouble is in C1, quite frankly, that's a bit tricky to solve algebraically, and we don't attempt to solve that in C1. We could of course solve it graphically if we're drawing the graph a bit more accurate, and there's various methods we can use to solve it. But as far as C1 goes, we're not going to worry about what the answers to that equation are.